Light behaves like a wave. As wavelength changes, we see different colors. For example, leaves appear green to our eyes because they mostly reflect green wavelengths. What else differs when wavelength changes? These images are taken by an infrared camera that captures from visible light to long infrared rays. Having long wavelengths, infrared images look completely different from visible light images that we normally see. Long infrared images capture an object's thermal radiation, unlike visible images that capture the reflected light. On the other hand, short wavelength infrared images look similar to visible light images since the wavelengths are close to visible light. Short wavelength infrared is known by the name SWIR. SWIR images, such as water or sugar, look different from images under visible light. This feature can be used for many applications. By applying Sony's original technology, SWIR, Sony SWIR image sensors are able to capture both visible and short wavelength infrared bands. Let's look at some applications of SWIR imaging. In SWIR images, wet areas look dark. Since water absorbs light at wavelengths near 1,450 nanometers, reflection is less likely at those wavelengths, so less light reaches the image sensor. In SWIR images, wet areas can be instantly recognized as they will appear darker due to less reflectivity. Using SWIR images, water and oil are easier to distinguish compared to visible light images. Bruises on apples are also easier to detect. Thanks to this characteristic, SWIR imaging is used in food inspection and similar applications. Materials that look similar in visible light can be distinguished in SWIR images by differences in reflectivity. As a result, SWIR imaging is also used in applications such as inspecting products for foreign material. Light in the SWIR band passes through silicon wafers used in semiconductor production and through some resin containers. As a result, SWIR imaging is also used in applications such as semiconductor production and filling inspections. Image sensors capture an object's thermal radiation as brightness. Visible light images can be taken from around 700 degrees Celsius and above. SWIR images can be taken from around 250 degrees. This example shows the difference between 250 and 300 degrees. This allows SWIR imaging to be used for monitoring the temperature of welds and other hot areas. Light in the SWIR band can be applied to many scenes, using its difference from visible light. Demand for SWIR sensors are increasing in many industries, such as medical, security, and resource observation. Sony's SWIR image sensor will make key contributions to attempts of industries to solve increasingly complex issues out in society.